All right, everybody, we're going to go ahead and get started. Thank you, everyone, for being here for today's seminar, and welcome back from break. If you had an opportunity to travel or spend time with friends and family, we're happy to have you back in our space. If you haven't been here, you haven't been here in a little while, these events are a hybrid event. So we have folks that are online and folks in the room. For folks that are online, we have your cameras, mics, and screen shares turned off, but we ask that you communicate with us using the chat function. If you have any issues using Zoom, which we are so well practiced on these days, or if you have any questions for today's speaker, we have Roseanne in the room, who's our volunteer. She will help navigate those questions with us. For folks in the room, just a reminder, if you haven't signed in, when you exit, can you do that for us? It's the way that we keep track of our outreach numbers for all of our presenters and justify our cookies. Also for you all in the room, because this is a hybrid event, if you have questions for today's speaker, just raise your hand and I'll bring you a mic, and that way folks online can hear the questions as well. A couple of quick announcements before we get started. I wanted to let folks know that next week's seminar on April 11th, Jessica Garwood, who's the assistant professor with CEOS at Hatfield and Oregon State University, is going to be talking about coastal transport pathways, interactions between ocean physics and ocean behavior. So hope you can join us then. And then it's Marine Science Day. Woohoo! On April 13th. And I think everyone in the room knows, but Marine Science Day is our big open house. We have about 2,000 folks that come and join us and look at all the great research that's happening here. We are still looking for volunteers. So I know most of the folks in the room are volunteering already by staffing a table, but anybody online and any family members of yours that might be interested, please contact me and we can get you scheduled so that you can help us out. There are 2-hour shifts to basically help volunteers move people around our different buildings. So if you're interested in that, help us and join us at Marine Science Day. But while the reason you are all here is for our presenter today, and we're very excited. And I'll just kind of do a little preview and say that today's presenter is helping me out quite a bit. We had a gap in our schedule. We had a last minute change, and I put out a call at our last seminar and said, does anybody have something in their pocket that they're willing to present? And today's speaker stepped up. And so I'm really excited to introduce Sarah here, who is new with the lead human dimension research with ODFW Marine Reserves Program. After majoring in biology and minoring in economics at Reed College, she worked for EcoTrust interviewing fishermen on the Oregon coast, helping to inform the creation of the reserves. She earned both her graduate degrees from the Institute of Resource Environment and Sustainability at the University of British Columbia. Her master's work focused on participatory GIS research that assessed social and cultural values to inform marine spatial planning. Her PhD focused on risk and benefit perceptions of onshore wind, as well as community engagement with island communities near proposed wind projects. And I'll just say, because she's kind of new to our community, her favorite hobbies are trail running with her pups, and playing at the beach with her kids, and attending her husband's bluegrass concerts. So welcome to the community, and thank you so much for sharing this work with us. I think she's going to tell you a little bit more about when she did this work in relation to what she's doing now. So I'm going to hand it off to Sarah. Thank you so much.
Great, thank you. Yes. Yeah, if anyone likes to jam on bluegrass, my husband's looking for new jamming buddies, so get in touch afterwards. Thanks for inviting me. I just overheard at the last talk that they had a gap, and I was like, you know what? I've done past research that I think is relevant to a current political hot potato in Oregon, and I want to start with this disclaimer. This is my academic research. It's pretty much my PhD dissertation projects -1. It's not ODFW research. It's my analysis of data. So please do not interpret what I say as how the agency thinks about this issue. So who am I? Well, I am an ecological economist, and a conservation social scientist. Many of you have probably heard of environmental economics, and fewer of you have likely heard of ecological economics. It's quite different. It sees the economy as being embedded within society and society embedded with the environment. Instead of building models where the environment provides natural resources as inputs into social systems, it has a much more embedded approach to looking at natural resource issues and challenges. Ecological economics is concerned about questions around what is the sustainable scale of production and consumption, which I think is a big question when it comes to energy on our globe today. It's also concerned about the fair distribution of services and the fair distribution of all sorts of things, whether it be services, how we organize our economy, and justice concerns. And then within fair distribution and sustainable scale, it asks questions about what is an efficient allocation of resources, sorry. So the aspiration of ecological economics is to make progress towards this green donut. Kate Raworth published this green donut. I think it encapsulates how I think about big picture issues where you've got both social considerations. So those are the humans need to consume water, food. We need certain levels of health, education, all those things in the inside area of this donut diagram in order for humanity to reach a social foundation, like a decent standard of living for all. And then we want to be within that light green donut without overshooting the ecological ceiling and leading to runaway ocean acidification, terrible catastrophic climate change, biodiversity loss, among other planetary boundaries. So this is very big picture thinking about where ecological economics is attempting to have us move, and that is making progress towards this safe and just space for humanity. So as a researcher, I am really concerned about information I read from the Intergovernmental Panel on Biodiversity and Ecosystem Services about this unprecedented decline in diversity across the planet. And the rate of extinction is accelerating with close to 1 million species threatened with extinction by 2060. Couple this with climate change. So you don't really need to pay attention to the parts per millions and the units here. The big picture I want you to take away from this chart is that our greenhouse gas emissions are currently on that red trajectory. And if we want to avoid catastrophic warming, we have to bend the curve of greenhouse gas emissions and get onto the green and blue paths. And then we got to even go negative emissions in order to create a global climate that is habitable to the number of people we have on the planet today. And this is an extremely tough challenge. And there is a giant gulf between our climate policy ambitions of staying within 1.5 degrees Celsius or 2 degrees Celsius warming and our reality. The reality is that greenhouse gas emissions are continuing to go up at a planetary scale. And energy consumption is increasing at 2% per year. I think this most recent year is even higher than 2% per year globally. And approximately 80% of that increase in energy consumption is from fossil fuels. We're not in a good place right now, and we don't have much time to, as Amory Lovins coined the term, reinvent fire. We really don't have much time to avoid catastrophic impacts from climate change. So in this reinvention of fire and bending the curve on greenhouse gas emissions, we need to transition our energy systems. And in most all roadmaps for understanding optimal ways to transition our energy system, there's a portfolio of options available to us. And in coastal places around much of the planet, offshore wind is part of that portfolio of different energy systems that could get us off of fossil fuels while maintaining the current levels of consumption of electricity globally. So in Europe, in northwestern Europe, offshore wind has already been built out at an industrial scale. I will add with the caveat that these are monopiles, not floating turbines, built out at large scale. So millions of people in Europe are already getting their electricity from offshore wind. It's a relatively nascent technology for North America. And when I started my research, there wasn't that much conversation beyond some special communities about offshore wind in North America. And just in the last 5 years, I think it's become a much more salient issue. So when I started my research, I had a question in my survey. I asked people, in your opinion, construction of offshore wind turbines off the coast of your state should be encouraged, tolerated, discouraged, prohibited, not sure. The vast majority of respondents answered encouraged. And this aligns with most other national scale surveys. However, when it comes to negotiating what constitutes both clean, i.e. no greenhouse gas emissions, and locally desirable energy systems, that is an ongoing debate at local and regional scales. And there's a lot of concern about aesthetic impacts and local environmental impacts and impacts to birds and some bats, among other concerns. You might have followed the Cape Wind proposal in Cape Cod, which did not happen, but there is a proposal going forward and actually under construction right now near the island of Vinalhaven, which I'll talk about more later. So there's been a lot of debate and a lot of concern about offshore wind. And I was really curious about this. I wanted to try to unpack all of these reasons for opposition and support. So the cartoon version of my dissertation, I should say, is what risks and benefits do people perceive associated with offshore wind farms? And that's the icon that will designate the slides on this question. And then I also wanted to ask a question that kind of turns the question on its head, which is, what if wind farms provide good marine habitat with artificial reefs? Are people willing to pay in their utility bill if they know their energy is coming from offshore wind that has artificial reefs and is good for some species of fish? And what are best practices for engaging communities near where these proposed offshore wind farms are going in? What are some lessons learned from both the where engagement was done well and where engagement fell apart in a few communities? So I'm going to start with my risk and benefit perception research, which resulted in this paper in Ecological Economics and my provocative title of my talk today. So which risks are most salient for people, and which benefits are most salient, and are there insights from cognitive psychology to help us anticipate the risks that come to top of mind for most people when thinking about offshore wind? So I dove into Kahneman's work, Thinking Fast and Thinking Slow. That book really impacted how I thought about this issue. Kahneman just died at the age of 90 last week. So I just want to mention him and how I feel like I stand on the shoulders of giants when I do this kind of research. His thinking shaped mine, and I wanted to use this model of cognition that he helped to develop and popularize. So in Kahneman's model of cognition, we have our system one thinking, which is more emotional, it's affective, and it's intuitive. And it's a really quick way of prioritizing threats. At the same time, we have our system two, which I hear Lisa Simpson is based on a compilation of Reed College women. So I have a special affinity for Lisa Simpson. And system two is what we train to develop in graduate school, which is that rational, deliberate, statistical, energy-intensive way of thinking and evaluating risks in a very structured way. So in thinking about this theory of cognition with your system one and system two that interact, whereas oftentimes we're not fully conscious of it, but our system one is driving a lot of how we live our lives. That model of cognition becomes embedded into this psychometric risk paradigm. So Paul Slovic in 1987 developed this risk paradigm. that divided how people perceive risks into two scales. You've got your dread scale, so risks that are not dreaded, and dreaded risks. And then you've got your how well is this risk known to science scale. And different technologies fall into these different blocks, and that results in different ways in which people perceive risk and the relative negative or positive affect that they have in relation to that risk. For example, we're not afraid of bicycles, and we are pretty aware of bike accidents, so the risks are relatively well known. The general public does not associate too much risk with bicycles. X-rays, the science of how they work is not really known well by the general public, but they're not dreaded because we really understand the benefits that they provide, and we're not too worried about getting an X-ray if we break a bone. And then there's technologies that fall into the quadrant of dreaded and known, like car accidents. And then the most problematic quadrant, which is the science is not that well known and they are dreaded. And it's this quadrant that provides the biggest problems, or I should say the biggest divide between expert valuations of risk and public perception of risk. So, for example, nuclear physicists and people with a lot of expertise in nuclear energy categorize it as low risk. And if you look purely at the numbers, at the quantified numbers of people who have died or been ill from radioactivity linked to atomic energy production, it's actually quite low in comparison to all the people that have been impacted by coal plants and other forms of generating electricity from a purely quantitative perspective. However, from a scariness, a dread perspective, we've got images of nuclear bombs and the idea that the waste is toxic to life for the next 10,000 years after it's spent. So there's all these ways in which it evokes fear from the general public. So I decided I wanted to use this psychometric risk paradigm, which demonstrates in this work how perceived risk is both predictable and quantifiable, and apply the psychometric risk paradigm to a new context that had never been applied to before. So I used this notion of ecosystem services, its contribution of nature to human well-being, popularized by the Millennium Ecosystem Assessment, and I wanted to understand to what extent does the psychometric risk paradigm help explain perception of risk associated with changes to ecosystem services in the context of a proposed offshore wind farm. I know that's kind of a long, convoluted way of thinking about it, but basically, you've got these offshore wind farms, they're gonna have some environmental impacts. What are the most salient environmental impacts to the general public or even to people whose livelihoods are connected to the ocean in some form? Are people going to react strongly to things that don't impact them directly, that are more indirect impacts, as in how much concern are people going to express about birds or the noise underwater from construction of offshore winds? So I tested this out in Golden Bay, New Zealand, which is a gorgeous area of the South Island. It's also largely protected, and it's an important nesting grounds for a lot of seabirds. It also has this strange and not very well understood pattern of whales beaching themselves rather frequently. And it has pretty shallow water and consistent wind. So biophysically, it would be a decent place for an offshore wind farm. And just to be clear, there is no proposed offshore wind farm going in here. It is just a hypothetical for research context that I used. So I conducted 23 in-depth, semi-structured interviews with people whose livelihoods were in one way or another related to natural resources and natural resource management. And I had this exercise where I gave people 20 symbolic tokens of benefits and 20 symbolic tokens of risk. And I asked them to allocate it across categories that I identified while leaving space for an other if they came up with a risk or a benefit that I had not come up with in my lit review. This is really hard to read, but I just wanted to quickly go over. In terms of benefits, the people that I interviewed were most interested in increasing regional energy self-sufficiency, increasing the diversity of their energy portfolio, contributing to energy independence, and reduction in carbon emissions associated with electricity generation was ranked 4th there. So there were some perception of some benefits. They did not think that it was going to have a positive visual impact, and largely did not think it would have a positive impact on tourism, and nobody added another topic there. And then when they weighted their concerns, impact on birds was weighted most heavily, followed by negative visual impact and impact on marine mammals. The stars represent types of ecosystem services. So from this data, and this is people allocating 20 tokens across different risks or concerns, I came up with this ecosystem service risk factor score that uses attributes of the psychometric risk paradigm. For example, let's say the impact of the wind farm on recreational fishing. I gave it I used this -1, +1 for attributes of the psychometric risk paradigm. Is it controllable, uncontrollable, not dreaded, dreaded, consequences not fatal, fatal, easily reduced, not easily reduced. And for each of these topics of concern, these ecosystem services of concern, I scored it +1 or -1 based on the qualitative data from my interviews where I talked with people about their concerns and had them explain to me why they were concerned about particular things. And so from this data, for commercial or recreational fishing, it was a controllable risk. It was not dreaded. The consequences of offshore wind to recreational fishing are not fatal, and they're somewhat easily reduced, as in you can just go to a slightly different fishing ground outside of the wind farm. So I came up with a -4 for recreational fishing. And I did this with all the other ecosystem services and came up with this R-square of 0.67 related to the ecosystem service risk factor score. So that's from the psychometric risk paradigm, and the tokens of concern that they distributed across these risks. So the dependent variable was the weighting of concerns associated with a potential wind farm, and the independent variable was the ecosystem service risk factor score. And this is preliminary evidence that the psychometric risk paradigm can indeed help predict how risky, or basically how scary, people think the impacts are going to be. And as you can see, people were really concerned about seabirds and marine mammals. Visual impact fell somewhere in the middle. And then they were less concerned about tourism, rec boating, rec fishing, and commercial fishing. So to sum it up, the risk paradigm may indeed anticipate relative risk perceptions, and it suggests that attributes of the psychometric risk paradigm can be used to anticipate the risks that are most salient to people. This can inform how you conduct stakeholder engagement processes. If you can kind of anticipate what things will be most scary to stakeholders, you can make sure that you are clear and transparent in addressing those specific concerns. It can also inform how you design risk management plans. And I also think, and I think there's a lot of room to improve here, that it ought to feed into figuring out how to design technology that can better reflect these risk perceptions and reduce risks to the things that people really care about. And there's ongoing research on that. Is it like, could we design the lighting systems in ways that scare away more birds so there's fewer strikes to birds? Does the color how does the color of the turbine impact its perception by animals and other things? So I think there's a lot of room to grow on that. I'm just going to show you the wind farm visualization, and Bohm and others have done far more sophisticated visualizations than I did for my project. But I think the visualization accompanies some of the quotes from my interviewees as well. So let's see if I can get this to work. This is the hypothetical offshore wind farm visualization that I showed to my interviewees. And I thought a custom visualization would help local residents envision an offshore wind farm in a familiar place. And one interview said, "I think the bird kill from those wind farms is massive, isn't it?" Another person said, "This makes me feel sick." Something like that would completely alter the view. Half the population of Golden Bay would think it would be a really good idea, and the other half would think it's a bloody disaster. Another person said, "These are amazing. I don't find them offensive at all. I think they're quite beautiful. They're almost like a sculpture in the right context. They're quite neat." Another person who I categorize as like a place protector said, "Your example of Farewell Spit, that's something that is very precious to me, and I would be prepared for there to be a windmill there if it is, as you say, one of the best places in New Zealand for offshore wind. So it's iconic to me, but I would still accept a windmill for the sake of not having to use petrol." And there's not necessarily a one-to-one there, but in some people's minds there is. So that's the wind farm visualization that I made with a colleague in Google Maps. And yeah, so my next study after this risk perception study, so we're going to shift gears a little bit here. These biodiversity concerns that were quite salient to many people that I interviewed got me thinking about how people perceive technology that could potentially benefit both people and other species. And I recognize that those win-wins are really rare. However, I think there's a lot more work that could be done to figure out ways that we could design renewable energy infrastructure that could provide natural habitat. For example, an offshore wind could also provide artificial reef habitat. And I wanted to see if that could elicit a positive affective response, and if that could potentially neutralize the negative affective responses to this technology. So that led to my next study, which was around basically asking, are people willing to pay more for their utility bill for electricity if they know that an offshore wind farm actually provides good marine habitat for diverse types of species? So I came up with, at the end of the study, perhaps the best academic title I've ever come up with, if you know Beatles music. And I also got to credit my friend who is a economist, a stand-up economist. So maybe the only in the world who helped me come up with this title. And I called it this wonky name, ecologically regenerative renewable energy. The lingo in the biz right now is net positive biodiversity impacts. More on that later. My basic question is, are people willing to pay more for wind farms with artificial reefs? And I wanted to measure people's preferences for different wind farm features. I used a choice experiment, which is a method from economics. And I also use this new ecological paradigm, it measures the extent to which people have an environmental worldview. My sample was 400 using Amazon's Mechanical Turk mode of sampling people, and I limited it to residents of coastal New England. So I used coastal New England because at the time when I was doing my research, that's where the first conversations about offshore wind were starting to take place. In coastal New England, you can build along the continental shelf and be slightly closer to land and build an offshore wind farm without having to rely on floating turbines. On the West Coast, it's much more emphasis on floating turbines. So in any case, in New England, I was looking at areas that had the potential for states with coastline where there was this potential for developing offshore wind. In a choice experiment, you have your base characteristics, and then your data my data that I present will be in relation to those base characteristics. So my base characteristics from my choice experiment was a negative 30% impact on biodiversity from an offshore wind farm, 1 mile from shore with private ownership. So I looked at these different attributes about impact to biodiversity, distance to shore as a proxy for aesthetic impact, and the type of ownership. Was it private, public, or cooperative? I found that people were willing to pay slightly more for offshore wind farms that were either state, municipal, or cooperatively owned rather than privately owned. Again, everything is in relation to these base attributes. I also found that there was this preference for offshore wind farms further from shore and willingness to pay to put them further offshore so that they wouldn't have to deal with as acute visual impacts. This aligns with lots of other research that's been done. I think it's part of why BOEM is focusing on federal waters to reduce the visual impact to coastal communities. I also broke down preferences related to biodiversity based on how people scored on the new ecological paradigm question. So this is the measure of environmental worldview. People who scored low on the NEP, the new ecological paradigm, tended to have a slightly negative willingness to pay. So they didn't want 60% loss, but that preference wasn't very strong. Whereas people who scored high on the new ecological paradigm, the longest bar there, they had a strong preference not to lose 60% diversity and abundance of marine species. And then I looked at a 30% gain. And here, how people scored on the environmentalist worldview didn't have that much of an impact on their willingness to pay to have a 30% gain to diversity and abundance. And then the strongest preferences were for an offshore wind farm that provided benefits to biodiversity, 60% gain in diversity and abundance. Is this in the realm of ecological reality? It depends. If it's a heavily trawled area that was just not managed that well in the past, and if you provide artificial reef, there's the possibility that you could actually bring a lot more diversity and abundance back. I will note there's also the risk of invasive species on new things that you put in the ocean. In any case, though, there is this latent willingness to pay for an offshore wind farm that could provide marine habitat benefits. And I think there's a lot more work to be done in the design phase to figure out how to do this in a way that could benefit not just people, but also other animals. So summing it up, there's this willingness to pay and preference for wind farms far from shore, ownership models other than private, and this latent willingness to pay for ecologically regenerative renewable energy. So that was quite theoretical. It was a survey where I presented people with these cartoon versions of reality. I wanted to go to real places and talk to real people in these controversies because it's inevitably controversial when these wind farms are proposed. So I partnered with the nonprofit group Island Institute, and we did this collaborative work on resulting in this paper, Will Communities Open Up to Offshore Wind? Lessons Learned from New England Islands in the US. And I had to use a Wyeth painting of a squawking seagull here because I love Wyeth. And there's lots of squawking that happened on these islands for good reasons often about this controversy. So I wanted to learn more about how community engagement was conducted near proposed offshore wind farms. What went well? What were the major challenges? And then I looked at to what extent do these experiences align with theory on analytic deliberative processes. In my talk, I'm going to go light on theory. If you want to look into that theory, it's in my paper, but I'm going to skim over the theory part of it and really talk about the practical part of it for this study. So I did this work with Suzanne McDonald in particular, who's now at NREL, and she was running the energy program at Island Institute. Again, we focus in New England, but on 3 specific communities. So Monhegan Island off the coast of Maine, Martha's Vineyard, Massachusetts, and Block Island. All of these are near proposed offshore wind. The Monhegan Island was near a proposed pilot floating turbine project that later got built in Scotland because Monhegan did not want it. I'll give you updates on where these projects are currently, but when I was doing this research, these were all in the proposal stage. So I used qualitative methods. I did this case study comparison. I Island Institute staff and I conducted key informant interviews. I did this document analysis of both gray literature and media on this topic, and I also did participant observation, and as did my Island Institute colleagues. And from that, we distilled some big picture takeaway lessons. And we found that stakeholder satisfaction was higher when there was two-way deliberative learning. And it did not go well when scientists, engineers, and experts came to communities and presented in ways that community members felt was condescending and didn't listen to their local values. So this is not rocket science. This has been proven many times, but I did want to reiterate it in the case of offshore wind. If you're involved in these processes, help people maybe avoid that common pitfall moving forward. So readily available and appropriate information, of course, that came up across the case studies that fed into processes that people felt went well. This notion of a trusted messenger was really important. In Block Island, they hired a local to be a local liaison between the developer and the regulators and the island community. This was somebody who had lived in the island a long time, knew a lot of people, was really trusted, and he was hired on, and I think he was paid by both the state government and somewhat by the developer. And he just had these open lines of communication that really helped move the process along and also helped them develop engagement efforts that were appropriate for that community. Bridging organizations played a key role, and by bridging organizations, I mean an organization like Island Institute that can translate the science to the communities and community values back to the scientists and the developers and the regulators to just help strengthen those networks and code switch to some extent, to be able to go from the technical to a more public audience communication, because good communication, no surprise, was very important for these kind of processes to go well. And I will also say that this is based on 3 case studies. Big picture, I'd say one of those processes did not go well based on the interviews and document analyses that I did. And then the other 2 case studies, there was a lot more positive affect associated with the process. And then the timing of engagement, more is better. And I know timing is a big issue with BOEM pushing forward really hard on certain processes right now. Based on my case studies, at least 1 year of engagement before specific sites are selected was associated with processes that went better. So my findings align with the theory on analytic deliberative processes. Again, I'll point you to the paper if you want to dig into the theory a little bit more. I also want to emphasize the point that it's not only procedural justice, it's also distributional justice. So both process and outcome are key to stakeholder satisfaction. And this analytic deliberative theory, it's more process oriented, and the deliberative learning themes did indeed align with what I found in the literature. I also found that community benefits are also key to satisfaction. And I know that Suzanne McDonald at NREL, me with this paper and this research, these community benefit agreements, which I'm so glad that those are getting more attention now. Hardly anybody was talking about CBAs in the context of offshore wind when I was doing my research, and that does seem to be integrated now into BOEM's selection of which developer they'll choose. So I'm pleased to see that community benefit agreements are getting a higher priority now. So the island of Block Island, a reason, not the reason, but a contributing reason to why there was community acceptance. Part of it was that they were able to negotiate a very context-specific benefit, which was a high-speed internet cable coupled with their electrical cable. They had never had high-speed internet before this electrical cable went in. So that was a largely public benefit, and especially institutions, schools, libraries, businesses benefited quite a bit from having that high-speed cable. So that's some big picture summary of my work. I think I'm approaching the time here. I just want to lob out some questions for you all. And, if there's a graduate student who's super interested in any of these, I'd love to, be on your committee now that I'm at ODFW. But these are questions that I think really need more attention. And that's related to one thing that there's this part of me that's like, oh my gosh, I published this dissertation and these papers, and there's actually been some uptake of some of the ideas. Like, I'm not taking credit for it at all, but you've got this company Ørsted that's claiming that they're going to do energy projects with a net positive impact on biodiversity. And I'm struggling to know how I feel about that. There's just this part of me that will always be skeptical of corporate industrial development. So I just want people to keep an eye on these large corporations that are getting billions of dollars of funding to do these mega infrastructure projects. And I want this to be true, but I think we need a lot more scientists figuring out how to make progress towards that net positive impact on biodiversity. And I can't help but put on my ecological economist hat, which is to say that we need to reduce material consumption and energy at a global scale in order to have a net positive impact on biodiversity. Yes, we need to address the climate crisis, and also we got to think about reducing overall material and energy use. So is this winds of change or corporate-driven hot air? I don't know, but we need lots of eyes watching these corporations as they industrialize or potentially industrialize parts of our ocean. I'll just leave you with this idea that most people in America are allergic to this concept. So I'll just let you read it here. It's more popular in Europe. It's the idea of degrowth, which when I first learned about degrowth, I was like, that's just a political non-starter in America. And it kind of still is, but I think more people need to learn more about this concept. And I'd be really curious to think about how do these constituent parts of degrowth map onto how renewables and offshore wind in particular are being developed in America right now, and where are they not aligning with how it's being developed? And are there opportunities to think about long-term, like when we decarbonize our electrical systems, energy systems, when will we have enough energy? When will we reach a level that is enough human consumption of natural resources? So I'll just put that radical idea in your head to rattle around in. And if you're interested, I can point you to several brilliant books to learn more about this topic. And then I saw this in the news the other day and I was like, oh, I really don't know how I feel about this. So we've got this high wind Tampen that's the world's first, it's going to be the first floating wind turbine. And it's going to be used to power offshore oil and gas platforms, which to me is just so puzzling because I thought so much of the motivation to develop offshore wind was to get off of fossil fuel development. So this stuff's a little tough for me to take. And I just wanted to point you out to like how that is happening. So in conclusion, my research reveals how this psychometric risk paradigm from cognitive psychology, it appears in this preliminary data to apply to concerns about ecosystem services. I showed in my choice experiment, there's this latent demand for ecologically regenerative design, or I should say net positive impact to biodiversity, if that's possible. And I presented a few ways around bidirectional learning, community benefit agreements, community benefits that you can address local concerns about renewable energy infrastructure. And moving forward, I hope that this research can help incorporate social dimensions into both conservation efforts and climate change responses. So I'd like to express gratitude towards all of the giants whose shoulders I stood on for this research. And I'll leave you with my favorite visualization of Gaia in my ecological economics worldview and open it up to questions from you. Thank you.
Thank you so very much for sharing with us. I'm going to guess we're going to have some questions about how this,
And again,
your work.
I do not represent ODFW's opinion on offshore wind. This is my academic research.
But I think we can have a good conversation about how some of this work might apply to what we are thinking about. But I'm going to start with folks online. Roseanne, do we have a question online?
Yes. How about the electric field around the submarine cable? How would it affect biota such as sharks, crabs, etc.?
I read about elasmobranchs, right? There's preliminary evidence that it has some impact. I don't know the magnitude of that impact. I would say it's an issue to continue doing research on that topic.
And we have some researchers in the room that have done some of that work. Do you want to speak to that at all? Or we want to hand that for another? Okay, we're working on that data. Stay tuned. Maybe a lecture in the future. So for folks online, the research in the room said, I agree, we should keep funding it. All right, how about questions in the room?
Thank you. Thanks. Just have a quick question. So the first your first paper that you presented talked about sort of the the different opinions of it. How does that change with scale? Because you talked about a fisherman who was like, oh, well, I'll just go around it and go out to a spot, or there's some biological destruction. But how does that change as that wind farm gets bigger?
I didn't test that question, but I can say from my read of the literature, people would much rather have smaller wind farms. My counter to that is, okay, but where do we get the energy from if we're going to get off of fossil fuels? And there has to be some middle ground between scaling it. Like, we're all accustomed to consuming a certain amount of electricity. Our businesses that support the tax base of our communities are accustomed to a certain price for energy. If we want to get off fossil fuels, the scale of renewable energy development that's necessary is kind of mind-boggling. So it does raise these issues, and people don't want to industrialize the seascape. I think it's a cliche, but I think when it comes to energy, it's pick your poison. All energy systems have consequences. And we got to think about the whole supply chain, from mining, the minerals that go into the wires that connect these offshore giant wind farms to the land, also the minerals and materials and cobalt and other things in the nacelles, the turbines themselves. But they're also like, there's yucky stuff in solar panels, and there's no kind of energy that has zero environmental impact. So the scale issue is really important. As an ecological economist, I would just urge us to think about reducing overall consumption and maximizing efficiency. If anyone's a real nerd, though, you got to look up Jevons paradox, or the rebound effect, which is with energy systems, if you make it cheaper and more abundant, people generally consume more of it. So there's this idea of like, oh, efficiency is the way to save us all. No, actually, like the Super Bowl LED light dome, that's a perfect example of that. LED lights are so efficient and cheap, and then what do? We put 1 million of them over a dome and have a Super Bowl there. So, okay, I'm going on tangents, but the scale issue is really important. The general public would like to have the energy infrastructure be as small as possible, but that's not feasible if we're going to meet these climate goals.
All right, question online.
What's your impression of how the process of offshore wind development has gone on the West Coast so far?
I don't know. Haha, that's the easiest one that I've gotten so far. I just got back into hearing more about the offshore wind development, and I'll only get in trouble if I speculate right now.
All right, we'll continue that conversation as we engage further along.
I'd ask Hillary Boudet at OSU, since she just got a big grant from the Department of Energy to look into that.
All right, questions in the room.
Hi, Sarah. In the New Zealand example, the graph of the relationship between the variables, commercial fishing was way down in sort of the low end of concern. And I'm curious, I mean, you've probably heard the general feeling around here that if you were to examine those variables around here, commercial fishing would probably be way up on the end of the curve with seabird impacts. Did you take those variables that are economically important to humans and kind of look at that relationship in a different way? We value seabird communities from a ecological perspective, but that's not necessarily a human economic impact, whereas there are lots of things on that scale that are relevant to the way you describe this good human space for well-being, commercial fisheries being a big one around here.
That's a great point, and I will say that's based on a small sample in a very distinct place. So I would love to have other people test out the psychometric risk paradigm in other locations, but my intuitive sense is that you're right, and that commercial fishing interests in this part of the world would be a much more salient, pressing concern than they were in that Farewell Spit area. I'd also say in the literature I've read, there have been examples in Scotland and other places where there's particular investments into figuring out how to employ fishermen or former fishermen, to employ them to do security or train them up with free courses on being wind farm technicians or some other way to provide jobs and training to help them be part of this new industry, I think is a way to try to address some of the livelihood concerns from reducing areas where they could fish. There's also there's some gear that you can use near wind farms, but nothing that hits the bottom or comes into contact with the electrical cables. And usually there's like a buffer zone where they don't allow commercial fishermen to go. But I think the commercial fishing industry, in Maine, they were really concerned about it. And it was also like, this felt like just another challenge to their livelihood. And they've dealt with so many leading up to that. So it's challenging. We also have to, recognize it's public space. It's not private property. And we have this climate crisis bearing down on us. So there's tough trade-offs that have to be made.
Roseanne, any other questions online? Okay, questions in the room?
Actually, building off of that last question, I mean, I've heard in Maine, Monhegan and Vinyl Haven, there have been, lobster boat protests and really strong backlash from the fishing fleet against offshore wind. But the projects, I think, are going ahead on Block Island, which also has, fishing communities around there. What did they do right, I guess, in Block Island? Was it just those community benefits that made people overlook, say, the risks to fishing? Or is it just a smaller part of the economy? Or, yeah, what did they do right?
I think it related to the scale question. It's 5 turbines. This is not some massive, big industrial scale thing. It's 5 turbines that are currently spinning. And Block Island used to burn, I think, close to 1 million gallons of diesel to provide electricity for their island. So there was this local air quality improvement. There was the internet cable coupled with the electrical cable. It also made the cable can both draw electricity from the mainland and transport electricity to the mainland. So it would contribute towards making electricity sometimes on these small islands. If for some reason your diesel generator has issues, it can go out. So there's more reliability with a cable underground to the mainland. So there's many contributing factors. Tourism is a major part of Block Island, and they've even been able to incorporate tours of the wind farm and get a lot of publicity because they were the first one on the US East Coast to basically host an offshore wind farm. So I'd say there's multiple factors that converged, and they hired that trusted liaison who is a trusted community member, and did lots and lots of consultation. I will say one of the anecdotes, again, this is an anecdote, but I think it made a difference, is to think creatively about how you do community engagement. And several people told me and the Island Institute staff that one of the most successful community engagement experiences that they funded to provide for the local community was a night modeled after a high school science fair, where you had experts with their 3-panel displays in a gymnasium, and they would chat with community members. And people felt like it was way less pressure than speaking up in a big town hall meeting where everybody's listening to you and you have a lot of people who are not accustomed to public speaking. They could just talk one-on-one with a developer, with an engineer, with a scientist, and chat about what that person does. And the scientists and the engineers could also like learn about like what's important to these people on this island. It was like it kind of leveled the playing field to some extent, and reduced like pressure and public speaking in a big, audience. So I encourage people to think creatively when it comes to community engagement, and it's not going to be just one thing. It's going to be a wide suite of things that you need to invest time and energy and care into if we're actually going to build this technology.
Sounds a little like Marine Science Day. Just saying. Okay, questions in the room. Hang on.
I had a question of whether you think there's any lessons learned from onshore wind farms, because, it's kind of the classic, conceptually everybody knows this is something we have to do. We have to have alternative resources, but there's always the not in my backyard syndrome, whether it's, offshore or onshore. So do you think like, say, Eastern Columbia River Gorge, where there's lots of wind turbines and they sit on farmers' lands and things like that, or other places, say in Southern California, that see this isn't so bad, even if it's fairly high density wind development, that it's doable and it doesn't really destroy their land. There's still the bird issue, obviously, but is there any thought about maybe looking at case studies there to see if there's lessons learned?
Yeah, I read a lot about onshore wind development. The biggest difference is that onshore is private property, and usually farmers or private landowners are paid for leasing their land to wind farm companies. And there's this stream of financial benefits that goes back to it. The offshore ones are different in some big ways, in that the amount of capital you need to do an offshore wind farm is like an order of magnitude higher than a land-based farm. And it's a whole different regulatory environment because it's public. A lot of the findings that I found, like, people do prefer smaller scale wind farms to bigger scale, but you've got the economy of scale, and the bigger the turbine, often the more efficiently you can produce that megawatt of energy. Land-based wind has also progressed faster in places accustomed to having industrial infrastructure in their environment. Guess which state has the most installed land-based wind? Texas, because they were used to having oil derricks in their landscape, and for various other reasons. They also have a lot of wind and private landowners who can make extra money. So there are a lot of lessons learned, but it is a different ballgame, and the costs of maintenance, the costs to construct it, decommissioning, all of those things are a lot more complicated. And I should have had this scale. BOEM has this slide of like just how big the proposed offshore wind turbines are. Correct me if I'm wrong, but like 500 feet high. Like, these are really big turbines, like bigger than anything we put on land. So there's lessons learned, but it's also a different situation.
I think we have lots of more questions and conversations we can have, but we're at our time. So I wanted to hand it back to you and say, is there anything else that you wanted to share with us about the process that's happening here, and maybe where your position might be going as you are getting your footing here with us?
I am technically in the Marine Reserves program. I am getting a little bit involved with some offshore wind. I am pleased to see that community benefit agreements are salient among the regulator and development circles that I've been glimpsing. And I also think that there is genuine concern for minimizing and mitigating environmental damage that may occur when these turbines go in. And I also just encourage everyone to think about the big question of like, when are we going to have enough energy? Because there's no free lunch. All energy has detrimental impacts. And as an ecological economist, we got to figure out how to have a world where people and the rest of nature can thrive, and humans are really dominating energy and material consumption right now. So I'll leave it at that. Happy to talk more. Thanks for having me.
All right, thank you. Go ahead. All right, thank you very much, and thank you all for being here. We'll see you again next week. All right, for folks online, we're going to end the presentation. Thanks so much for being here. We'll see you next week.